Oh yeah, here we go. Hello everybody, my name is Jan and I'm the founder and CEO of Apify, a full stack web scraping platform. And thanks for bearing with technical difficulties in the beginning. It worked on my computer before, so hopefully it will work now as well. And today I'm gonna talk about web data and LLMs. If you ever heard of both of those terms. All right. In my talk, I'm gonna cover like how are we doing scraping of web data for the large language models and their applications, and show you some tricks, tips and tricks that we developed on the way. But before we start, I don't really need to go into much detail here. But as you all know, all large language models have been trained on data scraped from the web, right? So kudos, scraping industry. Without us, there will be no AI revolution, right? So well done, everyone. This is just a snapshot. This is the last time that OpenAI released information about their training the data set. This was for GPT-3. It's a while ago. So they used mainly data from Common Crawl, web text, OCR scans of books, and obviously Wikipedia. All right, but there is a problem, right? Because the model only knows basically it extrapolates information about the world from the data it has been trained on, right? So it wouldn't know what happened after it has been trained. And so what happens is like sometimes it hallucinates, right? So here is an example of ChatGPT actually without external data. And when I ask it when was the first Web Data Extract Summit, it hallucinates. It was in November 2022, which is not true, right? So obviously this is the limitation of LLMs, right? They are just like these like funny generators of language, and they are really great at that, but they don't know about the world. But for that, thankfully, we have the RAG, Retrieval Augmented Generation, and basically it allows the large language model to query external knowledge or some other knowledge, and really combine the information acquired from external source with the understanding of the language to generate the answer, right? So ChatGPT, for quite some while now, it has this integrated web browser. So if the model infers it doesn't know basically the question you're asking, it will just query Bing and then like scrape like first couple of pages in the results to provide the answer. So if we do that, it will tell us the first Web Data Extract Summit took place on September 17, 2019 in Dublin. I hope that's correct. Very good. All right. So this is how it works really, right? Like, so this is like super simplified example of like how the RAG works. This is for let's say some customer support agent, right? So if you want to build customer support agent with LLMs, so you create some prompt and you effectively tell it like, imagine you are a friendly customer support agent. This is a super simplified prompt, and here is the external knowledge that might be relevant to answer the question. Here is the question from the customer, and now please generate the answer, right? So the model basically uses the external information with its understanding of the language to compile the answer, right? And sometimes it works quite well, sometimes it doesn't, but basically it can provide the context, the model with up-to-date context, and the tricky part really is how to find the external knowledge that is relevant to the query, right? So there has been like I would say quite booming industry, or like a lot of development about building these so-called RAG pipelines, which is basically to figure out like what kind of information we need to feed to the model to provide correct answers to questions that we might want, right? So it starts with the knowledge base. This is the data that we want to feed to the model. Well, it's split into the chunks, right? Those chunks, for them we compute embeddings, which is basically converting the words or tokens into these vectors, into numbers, storing into vector database, and then when somebody queries this vector database or this system, we do the same with the query, find the nearest sort of chunks that answer the query, and then like feed them into the context, to provide the answer, right? So this is like super simplified way. There's like the production systems look far more complicated than that, and they kind of can query different databases and different data sources and so on. But really, my point is, RAG is really the killer application of LLMs, right? Without RAG, LLMs are just like this funny generators of language, which might be great, to generate some poem or what, but like really not for commercial applications, very useful. But thanks to RAG, we can provide LLMs with up-to-date context. We can improve accuracy and reduce the hallucinations because we tell it exactly what information it should use to generate the answer. But what is most important, really, it reduces the cost, right? Like traditionally, when you were building AI models, you had to collect the data yourself, train the model, and then basically run the inference on your own machines. And it's quite complicated and quite expensive to do that. Plus you need to have the people in your team who know this. But with RAG and LLMs, you can just take off-the-shelf LLM model, feed it with external data, and for a couple of dollars you can have like AI application that actually works on your data and answers customer queries. And actually this is quite amazing, and I would say this is really what made the current LLM revolution big topic of the world now, right? So we're just missing one piece there in the whole puzzle, and that's the data, right? And as you all know here, the web is the largest source of data ever created in the history of humanity. But the problem is web scraping is getting ever more complicated. And as Joel mentioned before, it's not a World Wide Web, but it's World Wild Web. So there is a lot of, basically the data on the web is not very clean, and you can't use it right away. So how to deal with that, right? So first problem you encounter when you're scraping, right, is a dynamic web content. Basically, in the old days, we downloaded that HTML using some tool like curl or wget, and then you had it, right? But now, a lot of websites use like progressive web applications that query data on the fly and generate the web page basically dynamically. So for that, thankfully we have solution for past plenty of years called headless browsers. We have tools like Puppeteer, Playwright, so this is kind of solved. That's great. But unfortunately, like as you saw in the talk before, managing those browsers at scale brings a new set of challenges. And then obviously the blocking by target sites, it's on the rise. Like there is like new companies, new blocking solutions happening, being introduced all the time, right? So for that, obviously you need to use proxies. That's I would say like sort of like the hygienic factor. Like you need to use proxies. Like it's sort of prerequisite, but it doesn't solve it on its own now. So we saw recently you need to use like browser fingerprinting or different ways how to make your browser look as a human user. You might need to use CAPTCHA solvers. Actually, those are getting better thanks to AI. That's great. Actually, I read that CAPTCHA solvers, the AI ones, are now better than the human solvers. So maybe there will be a different way. Thankfully, those attempts by I think Google to introduce this like sort of like device identification has been kicked away. I think to big relief to all people in this room, And obviously, sometimes you might need to emulate human behavior, like moving the mouse and so on, right? But again, I think there's like plenty of solutions. A lot of companies in our industry are solving this. So let's say you download the HTML, but there is a lot of fluff, and you need to get rid of it, So if you're opening the website from the EU, actually, not only EU, I would say pretty much everywhere now, there is the cookie models that you want to get rid of, right? And why would you do that? Well, the problem is like, as we saw in one of those talks before, the HTML is huge, and really you need to like cut it down to the most important content that's relevant for the LLM. Because if it's too long, it's not very accurate. It costs much more money because you need to pay for much more tokens. So basically, you want to just strip it down to only the relevant content that's available on the page. So thankfully, we have a solution for that. It's called, for example, we're using this browser extension called I don't care about cookies, which is now maintained by Gen Digital, formerly Avast. So actually, there is like open source library so that you can embed this to your headless browser as well. And then obviously there is like when you open a web page, there is like a lot of content that is not relevant, typically to answer the customer queries, right? So for example, different menus, footers, scripts, and all that. So again, there are different ways how to do that. We found that, for example, using the readability.js, which is an open source library from Firefox, actually used for the reader mode in Firefox, actually works quite well on articles, not on all kinds of content, but quite often actually for these use cases, you'll be looking for articles or like knowledge bases, documentation sites, and so on. So that works quite well. So it can strip it down, and then you have to deal with all the other problems of scraping, right? Cookies and login, sitemaps, robots.txt, dealing with files, infinite scrolling, and then you want to make the whole thing scale to like millions of URLs, and yeah, it's quite tricky, right? So what we have built, just for context, Appify is a, as I mentioned, like full stack web scraping platform, and we have this marketplace of more than 2,000 ready-made tools for scraping, and actually not only for scraping, we call them actors. We have actors for all kinds of use cases. For example, for extracting data from the most popular sites, like social media, Google Maps, Google Search, and all that. We have also general tools to extract data, where you, for example, like provide just a piece of JavaScript code and so on. But we are actually missing a tool specific for this RAG use case, right? So we built one that's called Website Content Crawler, and actually we built it like early last year. Actually, I think it was like one of the first like scraping companies to specifically build for this use case. And yeah, it works the way that you just like enter the URLs of the site that you want to scrape, set up a couple of other parameters, and get basically the clean HTML or HTML converted to Markdown, which is actually a language supported by most LLMs at the moment, right? So I want to show you just quickly how it works. Now, fingers crossed, right? So you come to Appify, you select the website content crawler. Here I enter the start URL, which is the extract summit.io website. I'll actually just run it. Thankfully, the website is quite small, so this will be quick, hopefully. And you can actually control other parameters there, right? So for example, you can make the crawler use sitemaps, to include all the URLs. Also, it finds URLs on the pages, like traditional crawlers. Actually, we have a new feature now that some websites work quite well with like raw HTTP requests, and that's very efficient because obviously spinning up headless browser for every request, it's consuming a lot of resources, and you don't really want to do that all the time. But sometimes you have to. So we build this sort of like adaptive crawler mode that kind of tries to figure out like automatically whether the website works with raw HTTP or whether it needs a headless browser, right? So that kind of makes it more efficient. Then there are different crawler settings, like which URLs to include, which to exclude, and all that. Some limits, initial cookies to pass through login. Obviously, you can set up proxies here, and so on. And then there's a section that allows to control the HTML processing, right? So, for example, waiting for dynamic content. It's not exactly clear when the web page is loaded, so there are different approaches to that. Maximum scrolling. You can also remove some HTML elements just to make sure you're only getting the clean content. Remove cookie warnings, as we saw before. Expand iframes. That's also quite important because oftentimes the content on the web page is included in iframes, right? And with the naive approach, you wouldn't get this. But like for your LLM applications, you want the whole content. And then you can pick the HTML transformer, which is not the transformer known from the AI world, but just a transformation of the HTML. And you can, for example, use the readable text. Yeah, and let's see what it scraped. All right, so we can see there's like 10 pages, and I can select the markdown, and actually, yeah, this works. This looks pretty good. All right, so now let's say I have this data extracted, but I also want to store it in vector database, right? So what we have here, we have like another actor called Pinecone integration, and it actually allows us to store scrape data directly in the Pinecone database, right? So I prepared here a small index, actually a new index for this demo, and when I ran it, you know, I have this is like preset before, so you just enter your Pinecone API key, select the index name, you know, specify the settings for your embeddings and so on, and suddenly, you know, the data actually appears in the vector database here, right? All right. And actually, this Pinecone integration that we have built allows to automatically update the content. So, for example, like let's say if some page goes missing from the website, over time it will be removed also from the index, right? Because you only want up-to-date information in there, and then you can use this vector database and connect it into your RAG pipeline right away. And I have actually another example here. It's actually another actor that what it does is basically it connects to the Pinecone database and runs you know, ChatGPT model against the Pinecone database, and you know, provides like a chat interface, right? So let's try that, and we'll see. Oh, sorry, not this one. All right. So I'll just start it. Like I prefer the same index name here. So when I ran this before, without actually uploading the data from the Scrape website, you can see when I asked when was the first Web Data Extract Summit, it answered, I don't know when was the first Web Data Extract Summit was held. But now when I run it, now it's starting like the actor, and actually the actor can also like run a web server to which you can connect and open a web page with some interface, which will hopefully happen soon. All right, it's starting. Okay, and here, so now it should be connected to the right vector database index. And when I ask when was the first Web Data Extract Summit, actually I'll increase the size so that you can see it. Hopefully it will use the data scrape from the web to answer the question, right? It was held in 2019, right? Okay, and so like by combining a couple of actors we have built for this use case, you can easily integrate web data into your RAG pipelines, and basically all these solutions, they integrate quite well with LangChain and other tools from the AI and LLM ecosystem, like Llama Index and so on. Actually, this tool, or like Appify, was the first web scraper to integrate well with LangChain, right? Now there's plenty of others, but we were the first one to land the pull request in LangChain, and you can actually build your own actors on our platform, right? You can use our open source library called Crawly, which is actually maybe the most popular crawling library for Node.js. Recently, we also launched version for Python. So just take away some fame from scraping, maybe. We'll see. But anyway, it's basically a library that makes it easy to build crawlers, you know, and maintain the pools of browsers and so on. So you can build your own actor using these tools and publish it on Appify store, and even make some money if you want to. So that's it. Thank you for your attention, and
So one question came in online. Are you using self-hosted LLM or some cloud solution?
Currently, only like off-the-shelf solution. We didn't want to go that way. We use APIs for everything possible.
Yeah. Okay.
Oh, thank you very much. Do you also give the option for the user to regulate the prompts? Because you're using the vectorizer or let's say a chat completion. In the features you were showing, is it possible to, let's say, prompt and say, just give me the name of the presenters, so you get that only, not anything else?
Well, this last actor with the chat interface that I was showing, I think the prompt is hard-coded there. You would have to like, I don't think it allows customization of the prompt, but it would be like kind of easy to make it. Like, I think it's in open source, right? So it would be possible.
Awesome. It's possible then.
Yeah.
Very good.
Everything is possible.
Just a matter of time. When dealing with iframes, since CDP doesn't provide access to its content directory, do you need to iterate through the entire DOM for getting it?
Honestly, I don't know exactly, but I would assume like it's available on the CDP because otherwise I don't know how we would be getting it. But oh well, thanks.
Yeah, you do have to crawl the CDP JSON list. You go to Chrome, you say, hey, give me all your frames. Chrome will say, here are all your frames, and you can correlate these iframes belong to this top level frame, and then you can crawl it from there if you wanted to. But there are some APIs in Chrome DevTools where you can get like a pierced nested list of all iframes and shadow DOM trees too in it. They're just very expensive to run and difficult to work with.
By the way, this feature is part of Crowley as well. So basically, this actor I was showing, website content crawler, is just a thin wrapper over Crowley, right? So all of these things are available in open source.
Good. Take some more from the audience.
Hey, great presentation. How do you deal in the actor that crawls the content with things like infinite scroll?
Yeah. So I mean, it is to use headless browser or browser. Otherwise, infinite scrolling is very difficult. And yeah, so I think it works the way that you just specify the maximum sort of like y coordinate. It can go down, and it just like keeps scrolling, and it monitors the network if there are any new requests happening, and if not, it considers it loaded.
Does it happen automatically, or need to configure it?
Oh well, I think. The Crowley implements this as well, so there's a function for that, and internally it works this way basically. That it monitors the network, and if there are some requests that are still open, it doesn't consider it finished the scroll.
Okay, thanks.
So would the actor that generates Markdown, would that handle infinite scroll automatically?
Oh yeah, it does. Yeah.
Cool. Any other questions? Yeah.
Hi, thanks for the presentation. Super interesting stuff. When you do RAG, are you using chunking, or you're setting or passing the whole documents to the LLM?
So this Pinecone integration actor that I was showing as well, it does the chunking as well.
It does chunking.
Yeah. So currently it's quite simple. It does like fixed sort of length chunks with some overlap. But like very soon we'll add like a different versions sort of to maintain the paragraphs, the linked list, and so on.
Thank you.
Any other questions? No? Okay. Thank you very much.
Thank you very much. Hopefully it will work. Oh, right. Oh, sorry.
Take your time.